Hello, everybody, and welcome back to BlinkOn, Day 2. Me and sweet baby Toga over here both welcome you to the final day of BlinkOn. It's a little melancholy. It feels like only yesterday that I was welcoming you to Day 1 of BlinkOn, but that's all right. This final day will be another exciting day of lightning talks, workshops, and some fun messages at the end. Let's go through some quick announcements. Just like yesterday, you should be able to find the schedule on the Hop-In reception page. If you don't, just search for the BlinkOn 15 page on chromium.org. It also shows the schedule for these sessions. Networking, again, is going to be available throughout the day if you want to hop in for a quick couple minutes of low-pressure chat with a random person before it shuffles you off to somebody else. And once again, we'll be running it for an hour after the event, so from 12 to 1 p.m. Pacific. Finally, the recordings are not going to be available on Hop-In, like I said yesterday. We're going to be doing some light editing to them, so they will be available shortly on YouTube, a little bit after the close of this, possibly tomorrow. So the run of the show today is fairly similar to yesterday. We're going to start with lightning talks, again hosted by Kentaro, and then going into several rounds of sessions. Again, 2 at a time. You can attend either one. Feel free to hop between them if you find that one might be more interesting to you. After that, we'll have a special appearance for a History of the Web presentation. And to cap it all off, the end of the day, Ben Goodger will be addressing us with a special talk. So without further ado, we can move on to the start of the lightning talks. Thank you.
All right, so welcome everyone back to the BlinkOn Lightning Talk session. Are you excited? Okay, so let's celebrate. Today, I have 4 party poppers, and I'm going to pop the poppers in parallel. This is parallel execution, right? 1, 2, 3. Yay! Okay, so it happened again. So today we have 12 lightning talks. As always, I asked each speaker to insert one point where they can get a storm of applause. So please find that point and send a round of applause using the text chat. The speakers are also watching the session. All right, so let's get started.
Hello, my name is Ken Russell, and this lightning talk is on advancing web standards through collaboration with WebKit. For a little bit of background on WebGL2, this standard was released in 2017 in both Firefox and Chrome. It significantly expands the GPU-accelerated graphics functionality on the web, but by mid-2019, it had still not shipped in Safari, and therefore there was no WebGL2 on iOS. So how could we resolve this functionality gap? Well, it turns out that the Angle project, hosted by Google, implements the underlying OpenGL ES3 spec with the WebGL flavor. So we could just integrate Angle into WebKit, bind it to JavaScript, and profit. So here's an overview of the project. In June 2019, we had an in-person meeting with the WebKit folks to agree upon the project direction. And between July 2019 and October 2021, there was extensive work in WebKit's WebGL and Angle components. Roughly 400 bugs were fixed. And in October 2021, the functionality shipped in Safari 15. Here's a screenshot of the canonical and one of the initial WebGL2 demos running successfully in Safari on iOS. There were several great outcomes from this project. We developed a strong collaboration with the WebKit team. Apple developed a brand new metal shading language compiler for Angle. Apple also signed Google's CLA and is making crucial contributions now to the Angle project. The Google and Apple teams are working closely together, and this web standard is now universally available. Looking forward to the future, if there are major web standards gaps on iOS, perhaps the Blink team can consider helping implement features in WebKit directly. Perhaps this task was easier for WebGL since the implementation was largely self-contained in a separate library. However, there was still extensive work to be done in WebCore, and we did it together. On this project, we found the WebKit team was very receptive to help. The collaborative outcomes of this project were excellent, and we look forward to more.
Hi, my name is Matthias, and I work on Chrome DevTools. This lightning talk is about Blink's launch process for web platform features, and specifically the importance of keeping DevTools support in mind. To help you as feature implementers with this, we've recently made some improvements to the intents process and the tooling around it. In the Chrome status tool, which we can all use to kick off new intents, there has always been this debuggability field. But until recently, this field was often neglected or even ignored, which was understandable since there wasn't a clear description nor any guidelines on what to even enter here as a feature implementer. So let's clarify this a little bit. What this field is really asking is the following question. How can web developers using your new web platform feature inspect and debug their code that is making use of it? That is the question that needs a solid answer in this debuggability field. It doesn't necessarily mean that you as a feature owner need to implement a brand new DevTools panel in addition to your feature itself. In many cases, you won't even need to do anything special to get DevTools support working out of the box. But as a feature owner, you are responsible for formulating a good answer to this question. And the good news is that we recently made some changes to help you with that. We've created a DevTools support checklist that can be used to formulate your response. It points to concrete examples of various kinds of web platform features and what exactly tooling support looks like for them. Examples include new JavaScript language features, new WebAssembly features, new DOM interfaces and attributes, new DOM events, new CSS features, and so on. In many of these cases, you're able to simply rely on existing DevTools functionality and no additional implementation work is necessary. But in some cases, a minor change might be needed, which this document then describes. Either way, what's important is that you keep tooling support in mind while shipping your new feature. If anything is unclear or your situation is not covered by the current guide, then please reach out to the DevTools team and ask for input. The guide includes instructions on how to do that as well, and we are here to help. By the way, we've also updated the Chrome status tool itself by adding a description to the debuggability field, which includes a link to this new DevTools support checklist. So hopefully these changes help you to keep tooling support in mind as you're implementing your next feature. And that's it. Thank you for listening, and please feel free to reach out if you have any comments or questions. Take care.
Scroll unification. Here's a device. Here's your finger dragging the page. Or maybe you have a mouse wheel. Anyway, it's all input. Inputs produce events. What kind of events? Gesture scroll events. Scroll begin, update, 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 scroll end. That's a gesture. Actually, first the inputs produce touch events. Then the touch events produce gesture events. But let's focus on the gesture events. Where do they go? The renderer process. What's in there? A couple of threads. What's it rendering? Scrollers. Some are fast because they have composited layers. Some are slow because they don't. There are trade-offs here. The price of speed is memory and sometimes lower quality text rendering. On the fast path, the compositor thread handles the gesture event. On the slow path, the main thread handles the gesture event. This code lives in a different place, but it's doing the same stuff, like chaining to parent scrollers, running smooth scroll animations, snapping logic, boundary behavior and overscroll effects, hiding the address bar, interactions between the pinch zoom viewport and the layout viewport. We built all that stuff twice, once for the main thread and once for the compositor thread. That's architectural code debt. When Chrome was born, we only had the main thread. Over time, the compositor thread took on more responsibilities. But this duplication is brittle and slows us down. For example, scroll animations have complicated handoff logic to transfer an animation to the other thread. Let's clean it up. Scroll unification means handling all gesture scroll events on the compositor. We'll never handle them on the main thread. The fast path is still fast, and the slow path is still slow. The compositor thread updates the scroll tree, but if there's no composited layer, we won't see new pixels until the main thread repaints the scroller at the new offset. The slow path also goes to main and back to work out which scroller we're trying to scroll before we can properly handle the event. And as always, we'll run blocking event listeners on main. That happens before we even produce a gesture event. For now, main still handles scroll inputs that don't start as gesture events, like keyboard and custom scroll bars, and main still handles scrolls that are not from input at all, like JavaScript or navigation. But a single, unified path for handling gesture scroll events means we can add new features faster and fix bugs once instead of twice. Scroll unification is also a step toward making more scrolls fully parallel. It dovetails with the work that was done for the Composite After Paint project to give the compositor a richer understanding of the elements on the page. The next step is to do threaded, non-composited scrolls by rerunning the raster stage. In a way, it's the best of both worlds, high-quality text rendering and never waiting for the main thread, so we deliver a polished, responsive user experience. Scroll unification's been cooking for 6 years now, and we're in the final stages of burning down test failures. Out of thousands of tests, we're down to 25. We aim to launch experimentally before the end of the year, and roll out to everyone in Q1. Thanks for watching, and enjoy your scrolls.
Hi, I'm Yeonju from Igalia. To our great delight, Igalia had started contribute to MP-Arch with several works since March 2021. I'm really happy to share you our contribution history on MP-Arch projects in this lightning talk. Pre-rendering content restriction was the first work that Igalia joined in. This work was to ensure that web APIs are deferred by module capability contour in the pre-rendering content by adding web platform tests. Pre-rendering content restriction had done, and about 56% of tests was completed by Igalia. Also, Igalia submitted 47 CLs and added more than 60 web platform tests in this work. Fixing long tail of MP-Arch features is the next work after finishing pre-rendering content restriction. And we are actively working on now. The goal of this work is to unblock MP-Arch-based projects by updating codes to use proper public content API for MP-Arch. Also, browser tests should be added to verify browser features behavior in MP-Arch. As a first step, we participated on fixing long tail of pre-rendering on Android, and 23% of tasks was completed by Igalia. Related to this, Igalia landed 142 CLs and added more than 90 tests until October this year. Currently, Igalia is mainly working on fast frames for Android from mid-September this year. This work contains the similar work as the previous pre-rendering work. We are adding web platform tests for web platform features and browser tests for Chrome-specific or UI features. There are 2 more talks from us behind this. You can get details of our contributions on that wonderful talks. Thank you for listening this talk. Bye.
Hi, I'm Myung Sim from Igalia. I'd like to talk about how to work with platform tests for pre-rendering between render side and browser side. Before starting, we need some background. What is pre-rendering? We try to load web page before it is needed so that when it is needed, we can show them instantly. Please see the details from previous talks. Also, we should understand module capability control called MCC. It's to intercept all module interfaces before binding them to restrict web API features on pre-rendering pages. So we can control web APIs by granting, deferring, canceling, or killing. Please see the details from previous talk. It's quite simple to write WPT tests for pre-rendering. We create the broadcast channel to communicate with the pre-rendering page and open the pre-rendering page and waiting until getting the message from it. At the pre-rendering page, we connect the channel and we can check if this document is pre-rendering, then send the result to main test page and check the result. We support the same origin pre-rendering page, and the plan is to support the cross-origin pre-rendering as well. In case of same origin, we can expect to grant some web APIs without any blocking. So module interface for granting web APIs will be bound immediately, and we can get results during pre-rendering. If we don't register the module interfaces to map for the specific behaviors in MCC, it will be deployed basically during pre-rendering. So we can get the result in the test page after pre-rendering page is activated. The pre-render event correct API works to test this process. Pre-render processes are not trusted, so almost features that access the system are implemented on the browser side, but video features are implemented on renderer side. So they add callback to different map in the document during pre-rendering and invoke them after pre-rendering page is activated. But there is no difference from WPT test. If the features uses the module sync method during pre-rendering, we do cancel it. And if the feature required user activations is called it, we kill the renderer since it is unexpected. We can consider to write it as a browser test if it's difficult to write WPT test. Thank you.
Hi, I'm Julie from Igalia. I'll talk about tasks we handle in MPRs. If you take a look at the history in Chromium in the last 1 year, it's not hard to find some changes with the MPRs tag. And there are several talks about MPRs in the last 2 BlinkOns. For more information about MPRs, please take a look at them first. In this talk, I will not talk about the MPRs concept or details since there are several talks already. I will just simply share what MPRs means here. MPRs means multiple page architecture, and literally it makes to be able to host multiple pages in a single web content. With MPRs, we should review the current code, even though they already work properly and correctly as expected. In order to simply understand why we should do, I brought some example about manifest. Previously, updating manifest worked like this step. Blink recognized that the manifest is updated and it calls module interface to the browser. Once the browser gets the notification, it sends the notification to all observers. After MPRs, it's been changed like after the browser gets a notification, it checks if the document is active or not. Since the only primary document is active, if the page is in pre-rendering, it already returns and skips sending notification. After that, when the pre-rendered page is activated, it handles manifest. We also review the code that accesses the mainframe through web contents. As you can see, it was not weird to use get mainframe through web contents before, but after MPRs, the code needs to access the frame it is targeting like below. If the code aims to access the primary mainframe intentionally, it will be fine. Otherwise, what happens if we still use get mainframe? Let's just imagine that if did finish navigation is triggered by pre-rendering, then the code will work with the wrong target. There are many methods we could use from web contents observer. Among them, did finish navigation is one of the methods we are using when we check something for related UI. In that method, if we also check primary same document committed, primary page changes would be preferred. We also frequently use web contents user data when we want to store something related to tab data. With MPRs, some places might be using it to store per page data. There are several options we could choose instead of it. First, navigation handle user data. It stores data for an in-progress navigation. Second, document user data. It approximates the lifetime of a single Blink document. Last, page user data. It is attached to the page instead of any document. Thanks for listening.
Hi, my name is Joey, and for my lightning talk, I'm going to talk about auto-expanding details elements. For some background, the details element has a collapsible section which toggles when you click the label at the top of it. This was implemented in 2010, it's supported by all browsers, and is used by 2.3% of page loads, according to Chrome status. The problem this feature addresses is that find in page can't find any text inside closed details elements. If you want to search these, you'd have to manually click every details element in the page to open them, and then use find in page. The solution is to make find in page search these closed details elements and automatically expand them when they contain the active match. This feature also works when navigating to text fragments which target text inside a closed details element. A big performance problem with this feature is that find in page requires updated layout information in order to search for text. This is at odds with the current implementation of the details element, which uses display none to hide the contents when it's closed, meaning that there is no layout information at all. This means that every time a find in page query is run, we would have to build all the layout information and then throw it away again when the search is done, which is usually done multiple times when typing into find in page. Using content visibility gets around this problem because it can save the layout information of the closed section and still render it as closed, meaning that we only have to render the closed contents once, and then we can search it as many times as we want. The biggest challenge in implementing this feature was addressing the 44 bugs in content visibility reported by Clusterfuzz that were uncovered by this feature. Since this feature uses content visibility on a slot element, it combines content visibility with shadow DOM in a way that Clusterfuzz usually doesn't find on its own. A big privacy concern with this feature is that it may hint to the page what the user is typing into the find in page box. However, the existing vulnerability with scroll events already reveals more information to the page, and I'm working in parallel on a mitigation to strategically delay find in page queries in a way that makes it hard or impossible for the page to guess what the user is typing in the find in page, regardless of whether it's scroll events or auto-expanding details that the page is looking for. In conclusion, this feature has no developer opt-in needed and is shipping in M97. Thanks for watching, and I hope you have a wonderful BlinkOn.
Hi, I'm Richard from ARM's Android and Browser Enablement team. We normally talk about the big stuff at BlinkOn, but this time I'm going to focus on my side project, which is the HTML parser. When I started looking into this, I realized actually there are two HTML document parsers. So the primary HTML document parser focuses on things like document fragment parsing, and the background HTML parser focuses on things like page loading. And the reason why there's a separate background HTML parser is because it's designed to speculate around script tags. So it simulates what the ideal parsing path is, and normally this is fine. HTML parsing is very predictable. Sometimes though, we get an awkward document.write script, and this messes things up. So it changes the HTML tokenizer state, and we have to discard any work that we've done speculatively and redo it. So the idea was originally we'd move everything to one HTML document parser, and we realized that although it achieved a very complete first paint, it achieved a very slow first paint. So then the idea was, okay, well, can we make the HTML document parser more like the background parser and introduce a budget, and would this allow us to get to first paint sooner? And the answer seemed to be yes. So Pinpoint indicated that there were certain pages like Ars Technica that sped up a lot under this scheme. So I was obviously tremendously excited as a result of that Pinpoint run, and I decided to immediately get to work implementing it. The first supporting patches landed in 2018 and 19, but then some other projects came in, and it wasn't actually until May last year that I actually managed to land the parser. But, you know, it's landed, it's in there. So since then, we've been inching it closer to production readiness. We've fixed various state management and font loading issues. We've fixed various broken websites. And essentially by May, we seem to have fixed most of them. So we've now been focusing on things like budget trials and doing things like optimizing the performance and scheduling. We've also been recently trying to increase the Mojo buffer size, and this seems to improve the benefit of the HTML parser. So in February, we kind of started our first wide-scale trial. So we did see an expected improvement in first contentful paint. However, it was clear that there was a problem with content layout shift, so things moving about during page load. So we did lots of scheduling performance changes, lots of experiments with scripting and various other things to try and improve this. And currently it's looking good. So we're hopefully going to gather some more data from M96. Assuming that looks good, we'll hopefully go ahead with removal of the background parser, which will remove about 2,000 lines of code and close about 8 issues associated with this. So I'd like to especially thank Mason Freed for reviewing the code and running the trials. Couldn't have done it without you, so thank you. And thanks everybody for listening, and have a great BlinkOn.
This is a tale of a journey through the web unscripted. You find yourself adrift in a vessel with no engine, a webfaring craft with no working ignition, spark plug, or turbofan. What tools, old and new, can you use to journey the web? You recall the tale of no content and the sequel, reset content, which tell of HTTP status codes long forgotten, 204 and 205, which claim that a navigation can be complete while having no response body at all. This reminds you of the AJAX you now use to contact servers without leaving your contacts back when your vessel's engine worked. You grab your copy of HTML, the living standard, from the shelf in your cabin, and flip to the section entitled Process and Navigate Response. You find this old technique still works even in your newer vessel, the Chromium. You realize you also require a way to reveal to the server the specific coordinates you wish to locate. You try in vain to use all your trusty events. Click, double-click, mouse down, mouse up, mouse move, touch start, touch end, touch move, pointer down, pointer up, pointer move, and many more, but it's of no use. Events don't work without your JavaScript engine, and you're not much good at estimating distances or you wouldn't have been lost at sea. You recall two similar ways that might work, the isMap attribute and the image button control. You flip through the living standard again and find the passage you need under the section entitled Construct the entry list given a form, an optional submitter, and an optional encoding. You'll be able to indicate a coordinate to the server after all. You yearn to hear of the responses from the server, but dare not leave your current page lest you become even more lost. You recall a note in the blueprints of the Chromium, left by one of the architects, Yutaka, 5 years hence. Multi-part Xmix replace is only supported for images. But images will surely do. You're even planning on using one in a form control already. You consult the living standard again and find this too remains. Not one content to waste bandwidth or gaze upon blurry images, you pull out a current copy of Web Fundamentals and realize one of the modern components of your vessel doesn't require the V8 engine at all. You'll be able to tell the server the precise width of your viewport, so the images you do see are sharp and precise. At least you'll be able to keep up the image of modernity. Piecing these together, you make a web application, a collaborative drawing application, one which you can use to share rich visual messages back and forth with your compatriots at home. One which will show an image sharp and precise for each user. One which will allow the user to use great form controls to craft a clean and elegant drawing. One which will allow you to download the image for safekeeping, and one which does not use JavaScript at all. Your companion can scarcely believe you've done it. You unfurl the source code to show them there is no script in sight. You dock your vessel in port 443, feeling secure to have arrived home. You'll never take your V8 JavaScript engine for granted again, that's for sure. But neither will you forget your journey through the web, unscripted.
Hello everyone, my name is Benoit and I'm going to talk to you about PartitionAlloc Everywhere, and more precisely what's now new about it. And the main thing is that it's now almost everywhere. As usual, this is joint work with many people. It really takes a village, and I'm only here to represent them. So a long time ago, in a galaxy far, far away, PartitionAlloc was born in WebKit at the time to partition allocations, that is, separate them from each other. And you may have seen it with this using fastmalloc macro and its friends throughout Blink's code base. In 2020, we decided to extend it everywhere, to use it as a malloc replacement on every single platform to bring unity and also hopefully performance benefits. We shipped it in M89 and N90 to Windows and Android. And since then, what have we done? Well, we shipped it to Linux Chrome OS with macOS soon to come, and we've also improved performance and memory footprints. On Linux and Chrome OS, it is replacing TCmalloc. These two platforms are very interesting because they give us access to very neat performance tools. Overall, memory footprint improves by 15 to 20% depending on the process type you're looking at on Chrome OS. The performance is neutral, and it came with interesting challenges, which fortunately we managed to overcome, but some very nasty bugs. On the right-hand side, you can see the memory footprint of the network service on Chrome OS, and it's pretty obvious when we shipped the improvement. For performance, We've improved the fast path of the allocation by staring at assembly dumps, as you can see on the right-hand side, for hours on end, basically using all of the usual tricks, also improving thread local storage access. And the end result of all of that is that malloc is now roughly 25% faster than it was before. We've also improved the thread cache by looking at allocation patterns and specifically render allocation patterns that enabled us to increase the hit rate. And overall, that improves Pinometer 2.0 performance by roughly 1.5% at a very small memory cost. On the right-hand side, you can see on the far right when we shipped the improvement. On memory side, we've made sure that the thread cache doesn't use memory and doesn't trap memory in threads, even when they're idle, which is something which is very common in allocators. We've also made sure that the memory is reclaimed for the background processes. On the right-hand side, you can see the memory used by the thread cache going to almost zero whenever the process goes to background, which is the region in the middle. On the security front, we've brought MTE support, which is memory tagging extension that was contributed by ARM, and it actually shipped before any chip supporting it actually shipped. And we've also hardened the allocator. What's next? Well, we'll see at the next BlinkOn, but essentially we're going to improve performance, memory security, and finish shipping it. Thank you very much.
Hello everyone, this is Bartek with Chrome Memory team in Tokyo. Today I'd like to tell you about where we are with the Miracle Pointer project. This is a follow-up to our talk that we gave a year ago here at BlinkOn. Just a quick memory refresher. Miracle Pointer is our technology to mitigate use after free bugs by making them unexploitable. For that, we chose what we call a backup RefPTR algorithm, which in a nutshell wraps pointers in a row_PTR class and increments and decrements a reference count, which is provided by our allocator right in front of the allocation. When you try to free memory and the ref count is still greater than 0, the allocator quarantines and poisons that memory instead of returning it back to the system. I wanted to create a slide that describes the scope of the Miracle Pointer project, but for the sake of time, I'm not going to go over it. Please read it at your own leisure. And similar about the performance impact of backup RefPTR. For now, I just want to direct your attention to the last bullet because it will affect your lives as Chrome developers, and more about it later. Here where we are with the Miracle Pointer project. The backup RefPTR algorithm has been implemented and very thoroughly tested. PartitionAlloc everywhere, which is the key dependency for a Miracle Pointer, is now available on most of the platforms. Right now, we're wrestling with the evaluation of the overhead. And for that, we need to use so-called binary AB experiments, which in a nutshell is about releasing 2 binaries at the same time to different fractions of a population. And to be honest, it's been our nemesis for the last few months, but we're really hoping to be closer to the end than to the beginning of this evaluation. Once we can prove that the overhead is minimal, then we can land what we call the big rewrite and gradually enable the Miracle Pointer protection. As I mentioned, this will affect your lives as Chrome developers. So here's a slide about usage rules for row_PTR. I know it looks like a lot of text, but fear not. In 99% cases, the decision whether to use row pointer or the wrapper class will be trivial. And for those 1% of cases, remaining 1% cases, we wrote a detailed guide on how to detect and deal with those. Lastly, I want to thank the entire team for hard work and the community for huge support. We hope to make it happen soon. Thank you.
Hi, I'm Philip, and I want to share some of the results from this year's State of CSS survey. State of CSS is a community effort led by Sasha Grief, and it started as a spinoff of State of JS. It ran for the 3rd time this year, and over 8,500 web developers responded. This represents thousands of hours spent by web developers providing us with valuable data, so let's put the results to good use. So what is the state of CSS, generally speaking? In a word, it's fine. Web developers are pretty happy, but not ecstatic, just like this slightly smiling emoji. But let's go deeper. We asked web developers about their pain points, about which aspects of CSS they struggle the most with, and asked them to rank the options. Putting the results together, the top three were browser compatibility, architecture and maintenance, and form element styling. Let's take a closer look at browser compatibility. This is a pain point that everyone who has tried building for the web can relate to, and it comes through very strongly in most surveys of web developers. So it was no surprise to see it in this year's State of CSS survey too. Since we anticipated this, we asked web developers if there are any CSS features they had difficulties using because of differences between browsers. This was an open text field, and over 1,000 developers shared their experience. Some were very general, exclaiming that there are too many, but many pointed to specific areas like grid, flex, or SVG. Analyzing all of these answers, here's the picture that emerges. Despite big improvements around grid and flex over the course of 2021, these layout primitives are still top of mind for web developers. But other features like subgrid and backdrop filter aren't implemented in all browsers yet. So what should we do about these results? One thing we're doing is working with other browser vendors on an effort called Improp 2022. There, we're using signals about web developer needs, like state of CSS, to identify a handful of areas to jointly improve over the course of the next year. Now, of course, there's much more to the survey than browser compatibility, like what developers think is missing from CSS, which is useful when prioritizing new features. If you want to learn more about State of CSS and help take action, please head on over to 2021.stateofcss.com for the full results. And if you like, you can join the breakout session later today to discuss. I'll see you there.
All right, so thank you very much for many awesome updates and heartwarming messages in the text chat. So please send another round of applause to all the Lightning speakers. So if you are interested in specific topics, you can directly reach out to the speakers. So please do that. So great. Next time, I hope I can meet you in person. So see you at the next BlinkOn. Bye.